Hi, this is Mathematics for Social Justice by Mark Roth. On this video, I want to talk about a problem that I saw on YouTube. 2 over naught prime is equal to 1 over a positive integer plus 1 over a different positive integer. Let's say that b is greater than a. So the other presenter did a very nice video and proved this, but it turns out that it can be calculated that p is the harmonic mean of a and b. Harmonic mean being one of my favorite topics, I wanted to try to do the same problem using the harmonic mean, where the other presenter didn't use that concept. Okay, so now let's prove that p is the harmonic mean of a and b. So if we write 1 over a plus 1 over b, we can change that to a plus b divided by ab. And we still have 2 over p. Now, if we invert each of these, we have p over 2 equals ab over a plus b. And then if we multiply both sides by 2, we get p equals 2ab over a plus b. And that's the formula for harmonic mean. So now we've proved that p is the harmonic mean of a and b. So now we can use that. So suppose I start with A, B, M, and H. Again, arithmetic mean and harmonic mean of A and B. And now I'm going to write something below it. I'm going to multiply everything by M. So I'll make that MA, MB, M squared, and MH. When I do that, these will all be whole numbers, because this MH we know is equal to A times B. So if A and B are whole numbers, AB will be a whole number, MH will be a whole number. Now in particular, suppose MH is equal to P, a prime number. Okay, so since A times B is a prime number, and I want A and B to be whole numbers, this has to be 1 and this has to be p. That means this, m, is p plus 1 divided by 2. And so when I'm timesing by m, I'm really timesing by p plus 1 divided by 2. That means when I go from here to here, it's going to be p plus 1 divided by 2 times b, which is p. So it's going to be p times p plus 1 divided by 2. And when I times 1 by p plus 1 divided by 2, I get p plus 1 divided by 2. And m is p plus 1 divided by 2. It's going to be p plus 1 divided by 2 squared. So we have a formula. Let's look at an example. Suppose we want to find 2 over p equals 1 over a plus 1 over b. Let's pick a prime number like 7. So according to this is going to be the new a. Let's call it capital A for right now, and capital B. So this is going to be capital A and capital B. So capital A is going to be 7 plus 1 divided by 2. So it's going to be 4. And this is going to be 8 over 2, which is 4, times 7, 28. So let's see if that's true. Let's see if that's equal to 2 over 7. So this is going to be equal to 7 28ths plus 1/28 equals 8 28ths, which reduces to 2/7. So our result is basically capital A is equal to p plus 1 over 2, and capital B is equal to p times p plus 1 divided by 2. And that's what you plug in P for to get the 4 in this and the 28 in this case. Now let's go back and see if we can at least suggest a proof for uniqueness, that this will be the only A and B that will work. So I'm going to try to quickly review things I put in my other harmonic mean videos. So I made a discovery around the year 2000, which didn't seem to be very well known about the harmonic mean. And that's if you have, say, a number like 1 and 3, and you want to find the harmonic mean on the number line. Well, you just add 1 and 3 and get 4, and break this into 4 spaces. And then the harmonic mean is going to be 1 space to the right of 1. So that would be your H. Or equivalent, it's going to be 3 spaces to the left of 3. So it's still going to be H. So this would be your A, your B, and your M. So in this case, we would have 1.5, 2, and 2.5. So the claim is that M times H equals A times B. So 2 times 1.5 would be equal to 1 times 3. And that works. Let's look at another example. Suppose we have 2 and 4. M in the middle. And we add 2 and 4 and get 6, so we want 6 spaces. And then to calculate how long each space is, you take B minus A and you divide by B plus A. See, B minus A gives you this length, and B plus A is the number of spaces, because I chose B plus A to be equal to the number of spaces. So that means it's going to be 4 minus 2 over 4 plus 2, which is equal to 2 6, 1/3. So that's going to be 2 and 1/3, 2 and 2/3, 3, 3 and 1/3, 3 and 2/3. So then you go to A and look and see what number it is. That's 2. So you go 2 spaces to the right, and that'll be your H. Okay? Now, likewise, you could start here and go 4 spaces to the left. 1, 2, 3, 4. So that's the harmonic mean. So the claim is that M times H equals A times B. So 3 times 2 and 2/3 is equal to 2 times 4. And it turns out that's true, that both sides will be equal to 8. So if we want the harmonic mean to be a prime, in other words, we want it to be a whole number. So take this case here. The harmonic mean is not a whole number. Well, we can remedy that by multiplying by m. So if we do that, so A becomes MA, and H becomes MH, which is equal to A times B. And M becomes M squared, and B becomes MB. Now this is going to be a whole number because MH is equal to A times B. So if this is a whole number and this is a whole number, AB is a whole number. So MH will be a whole number. So we're going to end up with, we're timesing by 2. So this will be 2, 3, 4, 5, and 6. And we can see that 3 times 4 equals 2 times 6. Now, in this case, we do have a prime number. So we can go ahead and use our formula. So 6 should be P times P plus 1 divided by 2, which is 3 times 4 divided by 2, which turns out to be 6. And this should be just P plus 1 divided by 2, which is 2. So how are we getting uniqueness? Because I'm going to be doing everything in order. So I'm going to start, like if I have A and B, I'm going to start with 1 and 3. These two numbers add up to 4. And then I'm going to switch to 1 and 5, or 2 and 4. So there's one way to make 4, 2 ways to make 6. Then there's going to be 3 ways to make 8. So you could have 1 and 7, 2 and 6, or 3 and 5. And so in each case, some of these will give you your h to be a prime number. Some of them won't. But the prime numbers, occasionally you'll get a prime number. So let's look at another example. If you have, say, the prime number 5, that's going to be less than 9, and this is going to be 3, and this is going to be 15. Notice that 3 times 15 is 45, 5 times 9 is 45, and this is a prime number. There's actually a second way to do this. Instead of using the formula p times p plus 1 divided by 2, and p plus 1 divided by 2, what you can do instead is take the square root of 9. And the square root of 9 is 3. Okay? Now, every time you subtract here, I'm not going to do the calculation, but you can calculate that this difference will always be a square. Okay? There's a little bit of algebra to prove that this will be a square. The square could be 1, it could be 4, it could be 9. It's going to be a whole number square. But in this case, it's 4, which is the second square. So if it's a second square, what you do is take the square root of 9, which is 3, and times it by 2 because it's the second square. So 2 times 3 is 6. You would add 6, and you would subtract 6. So that's another way to get these two numbers. Let me do another example real quick. So suppose I have 16 here. And this is going to be 7. So when I subtract, I get a 9, okay? And 9 is the third square. So what I do is I take the square root of 16, which is 4, and I times that by 3 because I'm working with the third square. So 4 times 3 is 12. I add that and I get 28. And I subtract 12 and I get 4. Okay, so let's double check that 4 times 28 is equal to 7 times 16. So this is going to be 70 plus 42, that'll be 112. And this will also be 112 because I'm doubling 28 twice, 56, 112. So this is another example where this is a prime. And now, if you need to, we can check that it's going to be 2 over 7. It's going to be 1/4 plus 1/28. Now, why does this suggest a proof of uniqueness? Because I'm covering every possibility. I'm covering the possibility where I have these two numbers add to 4, or add to 6, or add to 8, or add to 10, on to infinity. What happens if you add two numbers and they're odd? Well, like suppose you take this example. If you have 1 and 4, for example, how do you know that won't produce a different result? That would be good. Well, you can just simply double everything and get 2 over 8. This turns itself into this, and this is one that we covered already. I'm suggesting this is a proof. I'm not sure it is, but I'm fairly convinced that I have a proof now that, for example, this result here would be unique when these are both whole numbers adding to 2 over a prime. So I'll stop at this point, and thank you for watching.